Example 1. Expand and simplify. And here we have an expression containing powers with rational exponents. So first let me copy it. So it's x to the power of negative 1/2 times bracket x to the power of 3/2 plus 2 times x to the power of 1/2 minus 3 times x to the power of negative 1/2. So this is the expression to simplify. First we expand it, so I multiply everything in the bracket by this factor here in front of it. So what I do is I first multiply first by first, so what I get is x to the power of negative 1/2 times x to the power of 3/2. Okay, so this is first by first. Then I take this factor and multiply it by the second term. So what I end up with is plus 2 times x to the power of negative 1/2 times, actually here there is the minus here, so let me correct it. So there is negative 1/2 times x to the power of positive 1/2. So this is the result of multiplying this factor in front with the middle term. And finally, I have to multiply first factor here with the last third term in the bracket. So the answer would be minus 3 times. So I put, as you can notice, I'm putting the constant factor, numerical factor in front. Now I copy the front factor, minus 1/2 times x to the minus 1/2. So this is the first preliminary step in which I copied what I have to multiply. Many people would just skip this and write the answer right away. So imagine if you want to multiply these two factors. The base is x and it's the same base. Now you can invoke the law that a to the power of x times a to the power of y equals a to the power of x plus y. So if you have a product of powers with the same base, what you do, you end up with the same base, but the power is the sum of powers, or the exponent is the sum of exponents. So in this case we should have x to the power of negative 1/2 plus 3/2. Okay, so this is the result of multiplication of the first two terms, actually factors here, plus now 2, I will just copy it in front, and I have to multiply it again, 2 powers with the same base x. So it should be according to the same formula as this one. It should be x to the power of negative 1/2 plus positive 1/2. So I have to sum the powers, and minus 3 times x, and again you have the same base, you have to add these powers, so it's minus 1/2 plus minus 1/2, which means you have to write minus 1/2, because if you add a negative number, it's the same as leaving out plus symbol. Okay, so this equals, now I have to add the fractions, so it's x to the power of, you can see, negative 1/2 plus 3/2 gives you 2/2, which is just 1. Okay, so it's just x to the power of 1. I just do not need to write power 1 because x itself is x to the power of 1, so I leave it as it is, plus 2 times. Here what I get is negative 1/2 plus positive 1/2, you get 0, so x to the power of 0. If you remember, a to the power of 0 is 1 for a different from 0. So here we have to suppose that x is different from 0 in this exercise. So yeah, this is something that was not mentioned here, but I will just write it. Okay, but this is also true for any power with rational exponents. So you can suppose that the base is different from 0 according to what has been said previously, yesterday perhaps. So what I have here is x to the power of 0, which is just 1, so it's just 2 times 1, which is 2. Okay, so this is replaced by 1, and then you have 2 times 1, which is 2, and now you have minus 3 times, and here you get minus 1/2 is negative 2 over 2, negative 2 halves, and what you get is negative 1, so it's x to the power of negative 1. Now you may remember that a to the power of negative n is always 1 over a to the power of n. So in this case our base here in the last term is x, so we can replace it somehow. So the first term is just copied, it's x plus 2, it's the second term, minus 3 times 1 over x. And since there is multiplication here, we can simplify it to the final form x plus 2 minus 3 over x. And this would be our answer.